Welcome back, everyone. We're going to be solving LeetCode 19, remove nth node from end of list. So we're given the head of a linked list. We need to remove the nth node from the end of the list and return the head. So another classic linked list problem where we are going to be using a dummy or a sentinel node at the start. So let's make that node. We'll say dummy is going to be equal to a list node. We're going to give it the value of none, and we are going to point this node to the head. And we are also going to find out the length of the list, right? We're going to have a loop. We'll loop through the length of the list. So we'll say length is going to be equal to 0 to start off, and we will set our current node equal to the dummy node. All right, now, actually, this should be dummy.next. Okay, let's loop through and grab the length. So we'll say while current node is not none, we just want to say current node equals current node.next, and then we will increment our length plus equals 1. All right, now let's print out our length just to see we get the right answer, right? So in example 1, we should have a length of 5 when we're done. And we do get that, perfect. Okay, so now that we have the length, what can we do in order to get the nth node from the list, right? Well, we can just subtract n from the length, right? That'll give us the node that we have to delete. Then we can do another pass through our linked list up to the node before the one that we want to delete, and then set this node's .next pointer to the .next pointer, right? So let's do that. Let's say we will reinitialize our current node to be equal to the dummy head, and we will say while the length is not equal to 0, actually let's do this first, length minus equals n. Okay, now we can increment our current node. So we'll say current will be current.next, and we will decrement our length by 1. All right, let's print out our current node after we run this loop. Give some spaces here, easier to read, so we'll run this. Okay, now we have the values 3, 4, and 5. Notice how we are 1 before the node that we want to delete. That's why we grabbed the length first and then subtracted n from it, right? This is so we could get this node right here. Now all we have to do is set current.next equal to current.next.next, and we don't have to have any additional cases here because we set up a dummy node. So if we had, example 2, right, doing this line wouldn't work because there is no .next. But because we set up a dummy node, now we do have this .next value in here. So that's why this line works, and that's why we set up a dummy head. So now, once we've done that, we've eliminated the node that we wanted to. What do we have to return? Well, they tell us we have to return the head. Well, where is the head? The head is at dummy.next. So let's return dummy.next. Perfect. And all 3 test cases pass, so we'll submit. Awesome, and it runs. And we've got a pretty good time complexity, although I don't tend to rely on LeetCode's time complexity analysis. All right, so time and space complexity, O of 1, right? We're not creating any new data structures to solve this problem. Time complexity, we're doing 1 pass through our linked list to get the length, right? That's O of n. And then we're doing another pass through the list to get to the node that we want, or the node before the node that we want to delete. So again, that's another O of n iteration. O of n plus O of n simplifies down to O of n. So our overall time complexity will be O of n. And that'll do it for LeetCode 19.